In the last two clips, we have looked at using the relationship between indices and logarithms to evaluate logarithmic expressions. Next, we are looking at the laws of logarithms, which provides us with guiding rules in carrying out basic arithmetic operations involving logarithmic expressions. The first of these rules states that if I have the logarithm of a number, say m, to some base, let's say logarithm of the number m to some given base a, and the logarithm of another number, or plus the logarithm of another number, say n, to the same base, which is important that the two of them are expressed to the same base, that the result is the same thing as multiplying both numbers and expressing to that same base. Logarithm of m plus logarithm of n is simply the logarithm of m times n. Let's look at an example. Here we have that the logarithm of 7, to simplify the logarithm of 7 plus logarithm of 3. Now we assume that both of them are expressed to the same base. So we have here that the log of 7 plus the log of 3. Taking the rule above, the law simply states that we should just multiply. When you are adding two different logarithm expressions, you can just multiply. So 7 times 3. And that this will give us the logarithm of 21. The very straightforward rule there. So that's it. Log 7 plus log 3 is equal to the logarithm of what? 7 times 3. And that gives us logarithm of 21. And another version, or the second law rather, not a different version, says that if I have the log of m, this time around I subtract the log of n from it, again assuming both of them the same base, that this will simply be the logarithm of m divided by n expressed to the same base. But before then, let's take another example first before looking at the second law. Here we have log 20 to base 10 plus log 50 to base 10 and log 2 to base 10. We are adding all these three up, applying the first law there. That will simply mean that this will be logarithm of what? 20, because this is addition. You just multiply by 50. Again, that's addition times 2 to the same base. This is expressed base 10, and that will give us the logarithm of what? 2000 to base 10. So that's it there. We can now look at the second law. The second law states again, as I stated earlier on, that the logarithm of m minus the logarithm of n, as long as they are expressed to the same base, that is equal to what? The logarithm of m divided by n expressed to that same base. So very straightforward rules. Consider here, simplify the logarithm of what? 30 minus the logarithm of 6 log 30 minus log 6. The rule says, very straightforward, take your 30 and divide it by 6 when you are subtracting and express to the same base. So we are assuming it's the same base there. So we have here logarithm of 5. That's it. Log 30 minus log 6 is equal to the log of 30 divided by 6 to give us logarithm of 5. Now, another example here, simplify the logarithm of 9 to base 5 plus log of 21 to base 5 minus the logarithm of 7 to base 5. Now, in this question, we are going to combine the first law and the second law. The first law will take care of this plus, and the second one handles the minus. Remember, the rule says when we have a plus, we should multiply. So here, this is 9 times 21. Then the minus says we should divide by 7. Of course, everything expressed to base 5. So we can write this out as simply as logarithm of what? 9 by 21 all over 7. That's the interpretation of that expression following the two laws we have just considered. And that's it there. That gives us 9 times 21 divided by 7. Of course, our 7 can take care of this. It's 1. Take care there. It's 3. And 9 times 3 gives us 27. So we have this as logarithm of 27 to base 5. So that's the first two laws of logarithms. And that brings us to the end of this video clip. We'll continue with the laws of logarithms in the next clip. See you.